Okay, we're going to talk about permutations when you're not using all of the objects that you have available. In the last video, when we talked about permutations, we just talked about permutations of n objects. So you have like 3 things, you want to order those 3 things. Or you have 10 things, you want to order those 10 things. And this is how you do it. Okay? So let's say that you had 10 Pokemon cards. Okay? And you wanted to arrange those 10 Pokemon cards, and you wanted to figure out how many different ways there are to do that. Well, there's 10 factorial ways to do that. Okay, we talked about why that is in the last video. The other question might be, well, what if I have 10 cards, but I don't want to choose all 10 of them, I only want to use 3 of them. And I want to see how many ways are there to order 3 cards, but I got 10 to choose from. Okay, that's a little bit different of a story, and it's a different formula. So let's go through a couple examples here that'll we're going to talk about to kind of distinguish between these two. Okay, so the first one is how many ways are there to choose a first, second, and third place from 3 runners in a race. Okay, so think about that. First, second, and third, that's an ordering. That's a specific order. Okay, so using the fundamental counting principle, there's 3 ways to choose the first place guy. There's 2. Once we choose the first place guy, there's only 2 runners left. So the same runner can't win first place and second place. And then the third runner, once we choose second place, there's only 1 guy left, and that's the guy we give third to. So there's 3 runners in this race. They're all going to get a medal or an award or whatever. That's the same as 3 factorial, right? Which we know is 6. Okay? So that's this guy, right? You're trying to order or arrange 3 objects, and you're going to use all 3 of them. Okay. This next one is a little bit different. How many ways to choose first, second, and third place from 5 runners in a race? Well, let's think about it with the fundamental counting principle. So we have to choose a first, a second, and a third place, right? Which means we're only going to choose 3 people. How many choices do we have for the first one? Well, there's 5 people to choose from this time. So there's 5 runners. We're still only going to choose 3 of them for this ordering, right? And the order is like we're ranking them first, second, third, right? So there's 5 runners for the first, or there's 5 choices for the first place. Then there's 4 choices for second place, because once we pick first place, there's only 4 guys left. And then once we pick second place, there's only 3 guys left to choose from. Okay. So that's how many different ways there are to get that first, second, and third ordering from 5 people racing. 5 times 4 times 3. So this is going to be 60. Okay. The question is, how do we represent this? How do we figure out, like, okay, 5 times 4 times 3. We can't say 5 factorial because that all goes down all the way to 1. So the idea is we use a division, kind of like we were doing in the first video. So what we could say is, so 5 times 4 times 3, what happened to the 2 times 1? We can just say we divided it out. So you could represent this as 5 factorial over 2 factorial, right? Because that would be 5 times 4 times 3 times 2 times 1, that's 5 factorial. On the bottom, you have 2 times 1 factorial, which is going to cancel. So this right here is 5 times 4 times 3. In other words, it's like, start at 5 and count down until you hit 2, and then don't use 2 and anything else below it. So with that idea of using the fundamental counting principle, we can kind of come up with a formula to represent this kind of choosing a permutation when you're not using all the objects. So we're talking about this, a permutation of n objects taken r at a time. So let's think about the numbers that are important here, the relevant numbers. We got a 5. Okay, where does that come from? That's the number of things we have to choose from. Okay, and then we have a 2. Oops, different color here. And where does that come from? Well, we have 3 things that we're choosing, right? So we're choosing 3 at a time, first, second, and third. Where does this 2 come from? Well, that's the difference between 5 and 2, right? So the idea is, another way to write this, is this is 5 factorial over 5 minus 3 factorial. In other words, where does this 2 come into play? The 2 is the difference between the number of things I have to choose from and the number of things I'm going to choose. Okay, so I have 5 things to choose from. I have 3 things I'm going to choose. The difference is 2. That's going to go on the bottom, right? And so this is how we represent that. Number of things to choose from, and the difference of the number of things to choose from and the number of things we're choosing goes on the bottom. Okay? So that's kind of what's going on there. 5 minus 3 factorial. So let's look at this guy. Okay, what does this mean? This means we have 7 things to choose from, and we're going to choose 4 of them. And we want to know how many orderings there are to do that. Okay? So how many different ways are there to order 4 objects from a list of 7? So what this means is we got to do 7 factorial over 7 minus 4 factorial. Now notice that the order of operations is important here, right? We got to do the parentheses first. So it's just saying find the difference of those guys. So you're like, okay, cool. So I have 7 things to choose from. I want to pick 4 of them and find all the different orderings of 4 objects from 7. That's 7 factorial over 3 factorial. Okay? And we could go on and figure out what that is, which we will in a minute. But let's just think about this for a second. Let's think about this as like runners or something, right? If you have 7 runners and you want the 1st, 2nd, 3rd, and 4th place, you got to choose 4 things. Fundamental counting principle, right? How many ways are there to choose the 1st place runner? There's 7, because there's 7 runners. How many ways are there to choose the 2nd place runner, or for the 2nd place runner to get decided? Well, once you have 1st place, there's 6 guys left. Okay? Once the 2nd place guy comes in, you have 5 guys left. And then 4 after that, right? So that's what we want. So we're just comparing different methods here. The fundamental counting principle says this should be 7 times 6 times 5 times 4. And that's true. That's exactly what we want to have here. If we compare that to what our formula says you got to do n factorial over n minus r factorial, which is this guy, right? 7 factorial over 3 factorial. Well, let's write that out. We'll come back to this one in a second. We just need more room. Okay? So 7 factorial over 3 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. Right? But hold on, cancel, cancel, cancel. So they all mean the same thing, right? That's the idea. This right here, it's a little confusing, but this is how you represent this idea. How would you say to somebody, okay, fundamental counting principle says put a space there for all the different choices you're going to make, and then put the number of choices you have for each one. That's what this one says. That's what this is kind of saying to do. If you have 7 objects you want to choose from, you got to choose 4 of them and order it, then do this. Right? 7 factorial over 7 minus 4 factorial. That's what the formula says. Okay, well that gives us this when we do 7 minus 4. Okay, well what does that mean? Expand it out? Oh, that's 7 times 6 times 5 times 4 when you see all the things cancel. Right, exactly. That is exactly what the fundamental counting principle would give you. And so this is a way of representing the fundamental counting principle in this scenario when you're talking about arrangements and you're talking about having to choose or having less options as you choose. So let's actually figure out what that is. Okay, so 7 times 6 times 5 times 4 is 840. So that would be the answer there. Okay. Let's do another one. Let's use a different notation, and then we might practice 1 or 2 more, because I know that can be a little bit tricky. Okay, so let's do a permutation. We're going to have 10 objects to choose from, and we're going to choose 2 of them. Okay, and we want to see how many different ways there are to arrange 2 objects from a list of 10, and all the different orderings of 2 that we could have. Okay, so again, let's just go with what the formula says, and then let's kind of put all the ideas together. The formula says this guy is n and this guy is r, right? Permutation, n and r. So the n goes here, the r goes here. You got to figure out where those go. Okay, so n factorial, that's the top guy. That's 10 factorial. Okay? All right, beneath that, we have whatever n minus r is factorial. So we could go 10 minus 2 factorial. So as long as you know that this is n and this is r, you just throw them in that template. Okay, no big deal. Just throw them in the template. Okay, let's simplify, because we can do 10 minus 2. We know what that is. This is 10 factorial over 8 factorial. Okay, let's keep going. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Pretty long, right? What's 8 factorial? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we got canceling happening here. 8, 7, 6, 5s, 4s, 3s, 2s, 1s. It all cancels, which is great. So this is actually just 10 times 9, which equals 90. Okay, there's 90 different ways. So let's say if we want to use the same kind of scenario, let's say we got 10 whatever runners, contestants. We want to pick a first place and a second place. How many different ways are there to do that? There's 90 different ways for that to happen. Okay, let's think about it from the fundamental counting principle. If you were just taking that scenario and saying, cool, you're going to choose 2 objects. Well, that's 2 choices. That's 2 events. Okay, there's 2 events here. Picking the first thing and then picking the second thing, because we're only going to pick 2 from this list. Well, we got to think about, well, how many different ways are there to pick the first thing? Well, there's 10 things to choose from, so there's 10 different ways to choose that first thing. As soon as that first thing has been established or picked, we can't pick it anymore, then we only have 9 more options. Okay? So 90. So whether you think about it, formula-wise, or you think about it from the fundamental counting principle, the answer is the same. Now, I think that this is a little more intuitive because we've already talked about the fundamental counting principle. So this idea makes a lot of sense. The difficulty with that is, how do you represent that mathematically? How do you explain that to somebody? Or how do you say, like, here's the formula for doing that? Right? You can explain it in words, but those words are going to change for different scenarios, right? Or they might be kind of a little bit unclear. That's why we have this thing right here. That's what this is telling you. Saying, hey, this idea here about the fundamental counting principle and like having less options every single time and putting them all together can be represented mathematically by this formula. Okay. Now there's one more way to represent this stuff, and that's here. This n with the capital P and then r, and these things become numbers. So we could do the same exact problem or represent the same exact question like this. 10 things to choose from. P for permutation. We want to choose 2 of them. Okay, that's the same kind of idea. Or we want orderings of 2 from a list of 10. So at the very beginning of this video, I think, we talked about like Pokemon cards or playing cards or whatever it happens to be, something you're collecting and you're like, stamps or whatever. So if you wanted to do that, this is just the idea of you have 10 cards to choose from. And you're going to pick 2 of them, and you want to think, how many different ways are there to order 2 cards from this list of 10, right? Really quick thing. So, again, that's 10 factorial over 8 factorial, which is 10 times 9, which is 90. Okay? So there's more than one way to represent it. You'll see this way or this way. But the n is kind of in the first position, and the r is in the second position. And this is the formula that represents that fundamental counting principle.